am trying this out. Hopefully it works well. It's going to have to be in several components because every time I stop my camera, it won't let me continue. But in any case, so the question is, initial velocity of a particle is directed northward and has the amplitude of v equals 0.6 meters per second. So it said northward, and v is the north-south component, positive being north, and it only gives v, so we can assume it starts with u equals 0. So v northward is initially 0.6 meters per second. The steady geostrophic component of the flow is also northward and has the amplitude of Vg equals 0.1 meters per second. Now that's going to actually very drastically simplify the problem, which we'll show in a second. So compute the displacement of the particle in x and y after 3.5 inertial periods, where t equals 7 pi divided by Coriolis force F. And another thing that very much simplified this is we're just literally saying F equals 10 to the negative 4 inverse seconds. So let me go up to, or let me switch to the PowerPoint now. Okay, we're going to get to this in a second, but before I get to this, what I want to highlight again is actually here. So remember earlier when we talked about the total velocity, and we're separating it into the u and v components, u being the horizontal component, v being the vertical component, and you remember that ui inertial plus ug geostrophic, and then v, same thing with v. Okay, but more importantly, take a look at these two equations. And what you can see is, you perform a simple integral where you're just integrating with respect to time. And what you actually end up with are these two equations, okay? So going over, going now to this slide, you see that these are going to be the equations that you want to use. Hopefully, okay, let's see here. Can you guys, let's see. Okay, so, bam. Alright, and part 2 will be me doing the problem.